Hello everyone, welcome to the Knowledge Series webinar from Tektronix. This webinar will be focusing on HDMI 2.0, the new rollout of HDMI specifications which is happening as we speak. The agenda for this webinar, we'll have a quick overview of what's happening on the HDMI specification and updates on the new test procedures. Please let us know if you have any specific questions. We'll answer at the end of the webinar and we'll take it up from there. For those of you who are new to HDMI, HDMI is the high definition multimedia interface, the de facto leader in consumer electronic space. We'll talk about more details of what's happening on the HDMI front in the coming slides. At a very high level, HDMI has been leading the consumer electronic interface standards for the last 10 plus years. The standards were introduced in 2003 in Rev 1.0, which had a data rate of 1.65 gigabit per second per lane, and went on to change to 1.4b, which has the data rate of 3.4 gigabit per second. And now with the latest turn of the specification, HDMI is reaching out to transmit 6 gigabit per second payload on each of the three data lanes. So that's a very high level overview of how HDMI has transitioned from being a 1.6 gig standard to a 6 gig standard. Let's look at the basics of HDMI. It's very important to understand what is new, what is changed before we go on to the new specification rollover. HDMI, as we can see here, very clearly is the digital interface for uncompressed audio video from the transmitter to the receiver. You have three data lanes and a very unique separate clock lane, which is very unique for HDMI standards. So the three data lanes, each of them, as we saw earlier, carries a maximum data rate of 3.4 gigabits per second, and the clock is in a separate lane. These are the four lanes which are termed the high-speed lanes of HDMI interface. The relationship between the clock and the data is in the ratio of 1:10. That means for a maximum data rate of 3.4 gigabit, the clock rate will be 165 megahertz. HDMI also has the low-speed handshaking bus, also known as the EDID bus, plus the encryption, which became very popular amongst the content providers to make HDMI the success story of the last decade. Also, HDMI has the consumer electronic control, through which we have the remote control capability using the single digital interconnect. HDMI 1.4 added, apart from the normal HDMI, the bidirectional Ethernet and audio return channel. With this, truly HDMI has become the single digital uncompressed audio video interface of choice and is now going on using the same architecture to the next rollover of specification, which we'll talk about in the coming slides, that is HDMI 2.0. We have learned the basics of the HDMI interface. Now we will see why HDMI is de facto leader in the consumer electronic interface of choice. We see here the market overview. This is taken from one of the popular surveys. We can see the adaptation of HDMI interface cutting across products. The new introductions are addressing the automotive segment, wherein the backseat entertainment display are going HDMI. We also have mobile phones which have adapted HDMI interface through the micro HDMI connector. We have HDMI make forays big time into the PC industry. That's why you see laptops and desktops with multiple HDMI interfaces available today. The digital camcorder has adapted the HDMI interface, and not to forget the legacy set-top boxes and the traditional high-definition TVs. So you see the adaptation of HDMI interface cutting across almost the entire product category or the ecosystem of the consumer electronic industry and also the PC industry, making new forays into the automotive sector and the advertisement sector, and HDMI is hence known as the king of the interfaces, particularly for the consumer electronic industry. We have learned about why HDMI has been so successful. Let us see how Tektronix, who has been one of the leading provider of the HDMI solution since 2002-2003 when the HDMI standards rolled out, and we continue to support HDMI in a big way going forward. The Tektronix HDMI 1.4b solution, which has been approved by the HDMI standards, basically focuses on a real-time scope which is used for analyzing the HDMI signals for source testing, an arbitrary waveform generator based receiver test capability, and the world-renowned TDR sampling scope based TDR measurement capability. Not just for the normal HDMI, these are the same set of equipments that are used for both HDMI and HEAC. This gives the customers the choice of ensuring that the same equipment they have invested in for normal HDMI is also used for HEAC, unlike the alternate solutions that are available in the industry today. Apart from the main equipments, what we see here, we have the entire portfolio of the fixtures, whether it is for Type D, which is micro HDMI for mobile phones, Type E for automotive, Type A, which is the normal HDMI, or the Type C connector, which is the mini HDMI, which is typically used in still cameras and handheld devices. We also have specific fixtures for HEAC and appropriate probes for HDMI, HEAC, and not to forget the entire bundling of the small components which are needed to make the whole solution work seamlessly through the HDMI accessory kit. Not to forget, Tektronix has already introduced a game changer in its own way, the protocol analyzer, which is based on the same real-time oscilloscope used for physical layer testing, and this is a new insight to particularly design companies who want to know what is happening between the physical layer and the link layer and solve problems what they see when they integrate the physical layer implementation and the link layer implementation into their final product. The biggest challenge today in the design community is how do you find out problems in the physical layer or link layer when the integration of these two implementation happens. Today they are in a blind spot. Tektronix protocol analyzer solution is the first of its kind in the industry, which ensures that the same real-time scope used for physical layer testing is also used for protocol testing and gives an insight which is the first of its kind in the industry in this category, wherein design engineers can at the same time find what the protocol view is and the analog view is. They can now find out why ones and zeros are getting distorted, which will have an impact on the link layer, and for the first time in a single view you can transition between the analog waveforms to the link layer pattern or protocol details of the HDMI stack. You see here a multi-view capability. You've got the frame viewer, not just the image. It also has the horizontal and vertical overhead bytes. So for once you have got the entire frame being decoded in near real-time basis, and the multi-view enables you to see the link between each of the views what we see here in one go. For example, if you click on a pixel of the frame what you see at the left side, it gets linked to the other views what we see here, whether it is a protocol detail view or the hexadecimal view. So this for once is giving the design engineers a real piece in terms of analyzing their problems during the design, implementation and integration phase. We have just seen that the Tektronix HDMI 1.4 solution is complete in all aspects with also the game-changing protocol analysis capability. That's very important because going forward, when we talk about HDMI 2.0, we need to understand that the HDMI 2.0 products have to be tested for 1.4b. So we have now the knowledge that a complete 1.4b solution from Tektronix is already approved in the CTS, and we now look forward as to what changes are happening in the new specifications. For the last 10 years, we had the HDMI standards body known famously as the 7C, represented by the 7 companies, and it was a closed standards body. We were, as test equipment solution providers, being consulted on need basis for some of the testing challenges. With the overwhelming success of HDMI, the industry standards body, that is the 7C, decided to open up the standards body and make it an open standards body, which is now called HDMI Forum. This was launched in 2011, October 25th, precisely when the HDMI Forum as a legal entity came into existence. This is separate from the HDMI 1.4b standards body, which will handle all the issues related to HDMI 1.4, while the HDMI Forum going forward will be responsible for handling issues, adaptation related to HDMI 2.0. The association of Tektronix with the standards body is a continuous process. We continue to be very actively associated with HDMI Forum. The forum as of today has got 89 companies as part of the current established members. And the challenge out there is the fact that we need to have an agreement on the specifications, on the test procedures, with the majority of the companies voting for these changes. Tektronix is a member of this HDMI forum and continues to be actively associated with the HDMI standards body. In fact, Tektronix has been with HDMI standards body since 2002. Tektronix has contributed the software clock recovery mechanism, which is adapted by the HDMI specification as way back in 2002. That's the technical insight to which Tektronix has been contributing to the specification. We have made some very innovative suggestions on how to address the changing high-speed lanes of the HDMI standards, and those have been accepted by the standards body and implemented in the CTS. Yours truly is the co-chair of the test subgroup currently, wherein we are discussing on how best we can make the test procedure which is easily reproducible by adapters when they use it for testing. The specification 2.0 was released on September 4th, 2013. The generic CTS is complete and we will have separate method of implementation documents from each of the test vendors. So this way it would be very easy for the test solution providers to update their MOIs on a need basis rather than wait for a timely rollover of the CTS. Now let's focus on some of the features of HDMI 2.0. The most important and compelling point is HDMI 2.0 uses the same category 2 cable and HDMI 1.4b connector. This was a very conscious decision made to ensure that there is no major disruption in the adaptation when the specification rolls over to 2.0. The HDMI 2.0 basically is supporting 4K, 2K, 4:4:4, 60 Hz or 50 Hz refresh rate at a data rate of 594 mega characters per second per channel. The MCSC is a new jargon introduced by HDMI Forum for 2.0. You can relate this to be equivalent to what we had in 1.4 as gigabits per second, 3.4 gigabit per second or 1.65 gigabit per second. We now have the 594 MCSC, mega characters per second per channel, basically related to 595.94 gigabit per second. Also, the 2.0 feature will have a sub feature of 420 format, 4K, 2K, 420 with a rate of 297 MCSC. There are new 3D features, 21:9 aspect ratio feature and new audio capabilities added into the 2.0 specification. HDMI 2.0 for the first time tries to get into the new receiver test capability which has been adapted by other standards currently, which is the low level bit error rate testing. This is first of its kind for HDMI, and we will have to wait and watch how fast this will be adapted by the adapters in their implementations. The major change is the fact that the signals are scrambled in HDMI 2.0. This is a mandatory feature. If your product is an HDMI 2.0 product, ensure that the signals are scrambled. Scrambling is optional for new devices which are going to be working at 1.4 data rates. So scrambling is mandatory for 2.0 but optional for 1.4 feature products. And the most important thing is the fact that your 2.0 product, since it has to work with other legacy products which is already available worldwide, needs to pass the CTS 1.4b. And this ensures that the interoperability and backward compatibility amongst various category of HDMI devices is ensured. With the new rollover of the HDMI specifications, that is HDMI 2.0, handling higher and high-speed data rates at 6 gigabit or 5.94 mega characters per second per channel to be precise, we need new set of test equipments which can handle these high-speed signals. So now let's look at the system recommendation from the test equipment point of view for source testing. The HDMI 2.0 data signal rise and fall time specification is 42.5 picosecond. So you need to have a test equipment, basically a real-time oscilloscope, which can measure this very fast rise fall time data lanes of HDMI 2.0. So we recommend a 16 GHz bandwidth oscilloscope from Tektronix for HDMI 2.0 testing. Of course, we will also support the 12.5 gig bandwidth oscilloscope to meet your economics of scale needs. The P7313 SMA probe, which are the same differential probes used in HDMI 1.4b, are good to go for HDMI 2.0. You will need a new option HDM and HDMDS for HDMI 2.0 testing. These are the software application packages that are available from Tektronix. You need the HDMI 2.0 fixture set. So this is what you need for HDMI 2.0 source testing. Now that we have understood the basic equipments needed for HDMI 2.0 source testing, let's go into the details of the HDMI 2.0 source tests. Before we dive deep into the HDMI 2.0 source tests, let us take a quick look as what is the difference between the 1.4b testing, source testing, and 2.0 source tests. First and foremost, the eye diagram and clock jitter tests in HDMI 2.0 are performed at TP2 equalized, which is different from what we did in 1.4b, which was at the TP1 test point. There is a new test added in HDMI 2.0, which is the differential voltage test. We will see why this was added, what was the need for this new test. And the rest of the tests of HDMI 2.0 are similar to what we did in HDMI 1.4b, whether it is a rise and fall time test, VLOW test, or the clock duty cycle test, inter-pair skew test. All of them are exactly similar to what we did in 1.4b. The other thing, as stated earlier, is the fact that your 2.0 product should not only pass 2.0 compliance test but also should pass 1.4b compliance test to ensure that the backward compatibility with other devices are taken care of. We have already seen that the bandwidth of the real-time oscilloscope needed for 2.0 is 16 gig or 12.5 gig based on economics of scale, and this is different from what we had for 1.4b, where a minimum 8 gig bandwidth oscilloscope was sufficient. So these are some of the changes you need to keep in mind when you are investing on 2.0 test equipment. Let's now focus on the source electrical tests. We have the VLOW test, which is very similar to what we did in HDMI 1.4b. The rise and fall time test is also very similar. Inter-pair skew test in HDMI 2.0 is also following the same methodology like in HDMI 1.4b. The intra-pair skew remains the same. As stated earlier, the differential voltage test HF1-5 is a new test added. Clock duty cycle remains very similar to what we did in 1.4b. And as indicated earlier, the clock jitter test and the data eye diagram test are now performed at test point 2 instead of test point 1 what we did in 1.4b. There is a source differential impedance test added, which is new for HDMI, and this test is performed using a sampling scope, and the DUT in this particular test has to be turned on. So these are some of the major tests which are to be performed to ensure that your HDMI 2.0 product meets the electrical compliance specification. Now that we know that the eye diagram testing has been modified, let's look at the eye diagram test needs in much more detail. As stated, the eye diagram test in HDMI 2.0 is performed at test point 2 with an equalized eye, and the signal has to pass through the worst cable condition. So that means this worst cable condition will have worst attenuation and the skew of 112 picosecond. So the setup for eye diagram now gets a bit different from what we did in 1.4b. The clock signal is connected through a differential probe, and one of the data lanes is now connected in the single-ended fashion, and it has to pass through an cable emulator which will have a worst case attenuation and a worst case skew of 112 picosecond, and we render the eye diagram using the equalizer and look at any failure in the eye diagram in terms of eye mask violation. So that's as simple as the eye diagram test gets. The point to note here is the unused data lanes have to be terminated to 50 ohm and pulled up to 3.3 volt to ensure that the entire design requirement of HDMI2 is met. So basically, the data connection is single-ended while the clock is connected in differential. The signal of the data lane has to pass through a cable emulator, either in hardware or, like we have shown here, Tektronix has adapted the software implementation of the cable emulator, pass through a 112 picosecond skew before the eye is rendered using the equalizer circuitry or the equalizer filter that has been approved in the HDMI 2.0. The connection diagram for the HDMI 2.0 eye diagram is depicted in this particular slide. You have got the clock signal connected in a differential way, so it occupies one channel of the oscilloscope, while the data signal, the data lane, is connected in the single-ended fashion using the remaining two P7313 SMA probes. So for each and every eye diagram testing, the three channels of the oscilloscope is occupied. So you have to perform the eye diagram test for the remaining two lanes in a manual method, that means one after the other. There is a potential possibility of leveraging this to be automated using an RF switch. Look out for an alert from Tektronix as soon as that feature is made available. The unused lanes can be terminated using a bias T and pull it up to 3.3 volts. We also provide a very easy way of doing that with a termination board which is available from the Tektronix ordering system. Here is the HDMI 2.0 eye diagram rendered, which is an equalized eye diagram, and this is the first eye diagram kind of from the prototype devices which we tested. What you notice significantly different from HDMI 1.4 is the top and bottom mask of the eye mask not seen here. Basically, you do not have any top and bottom mask defined in HDMI 2.0, only the central mask at TP2 is used. The reason for that is we are performing the eye diagram test at the TP2 point with an equalizer in place, and there is no point in having the top and bottom mask because a signal which has a bit of a pre-emphasis would get amplified passing through the equalizer and invariably would violate the top and bottom mask. So that's the primary reason why the top and bottom mask have been taken away in HDMI 2.0. However, to overcome this particular aspect of technicality, what we have added is the differential voltage test at TP1 to ensure that the signal level does not exceed plus or minus 780 millivolts. So, with the removal of the top and bottom mask, if any design team was looking at ways and means of adapting pre-emphasis levels, that's also under control now with the test of differential voltage added, and the TP1 signals should not exceed plus or minus 780 millivolts. Here is a quick snapshot of the Tektronix HDMI 2.0 transmitter compliance software. You have got the data rate selection, you have got the lane selection in the front panel, then you go into the test selection. You can select individual tests one at a time, or you can do select all. The software takes through the entire source test in a very automated way, exactly as per the CTS 2.0, and we get a pass or fail verdict. Not only that, we also provide the margin of each of these tests. This gives an insight as to how much margin your product has, and that would be a crucial differentiator when you market your products into the customer needs. The margin test capability or the margin feature of your products would likely to be the differentiator amongst your competing products. Till now, we have had a detailed insight as to what HDMI 2.0 is all about, what are the source tests, what changes are there between 1.4b and 2.0 in the source tests, and the Tektronix 2.0 transmitter solution or source solution software. We now focus the attention on the more complex and time-consuming tests, which has been a pain point in the HDMI community, so to say, which are the HDMI sync testing, and we focus now on HDMI 2.0 sync testing. Before we go into the details of the test, let us focus on the test equipments needed for HDMI 2.0 sync testing. You invariably need the 16 GHz oscilloscope, as we stated earlier during the source test discussion. You need at least two 7313 SMA probes for signal verification. You need option HDM and HDM-DS, which are the new options for the application software for HDMI 2.0. You need the 2.0 fixture set, and of course you need the signal generators, the industry leading arbitrary waveform generator, whether it is the latest state-of-the-art AWG7002A or the legacy AWG7122C. You need two of them in order to ensure that all the four lanes of the HDMI needs are being transmitted. So basically, we continue to adapt the industry proven direct synthesis methodology of the AWG, which we introduced in HDMI 1.4b into 2.0. Let's look at what is required for HDMI sync testing, particularly from the signal generation point of view. As per the CTS requirement, you need to have a signal generator which can generate the HDMI 2.0 signals. These signals should pass through an hardware cable emulator and 112 picosecond delay line in order to emulate the worst case cable condition. This impaired signal is then given to the sync device, and a visual check or an error count check is performed based on what feature is adapted by the receiver chip. Tektronix, as stated earlier, has innovated the direct synthesis methodology and ensured that the pain point of the HDMI community is addressed in a very good way. We continue to leverage that, and we have the cable emulator now part of the same AWG which we used for HDMI 1.4 sync testing. So the direct synthesis capability of Tektronix continues to ease the pain point of the HDMI community going into HDMI 2.0. However, the 112 picosecond delay has to be part of the hardware, and we are trying to see how best we can make this as software. Probably you will hear more about this in the coming months, but for now the cable emulator effect is part of the AWG. That means we are leveraging the direct synthesis capability of our solution, and we need the 112 picosecond delay line externally applied through hardware components. before the device is verified using a real-time oscilloscope, and once verified, we then perform the sync testing by connecting this impaired signal coming out of the HDMI signal generator to the sync device and perform the tests. Now let's focus much more detail on the sync electrical test. We have the min-max differential swing tolerance test, which is very similar to what we did in HDMI 1.4b, intra-pair skew test, jitter tolerance test, and differential impedance test. The only difference is in the jitter tolerance test and the intra-pair skew test, we need to apply the 112 picosecond delay line, which is new for HDMI 2.0. This increases the test times because there is human intervention in order to insert the 112 picosecond delay line first on the positive lanes, complete the test, remove them, put it onto the negative lanes before we can complete the test. So that is inevitable, and we are trying to see how best we can make the whole testing environment much better. Hopefully you will hear more about the complete automation capability using the software capability of the Tektronix direct synthesis. For now, the cable emulator is directly synthesized in the AWG, while we need to use the hardware 112 picosecond delay line. A quick snapshot of the Tektronix 2.0 sync test setup. You need the two AWGs because we need 4 lane coming out of these for clock and 3 data lanes simultaneously. We very smartly use the AFG to synchronize and trigger the two AWGs, and the cable emulator effect is embedded in the AWG. We however need the 112 picosecond delay line applied externally. These signals are then fed into the DUT, device under test, through the HDMI2 fixture. One thing to note, HDMI2 signals are all scrambled. Even the source device should scramble and transmit the HDMI2 signal, and the sync testing, we generate scrambled HDMI2 signals and give it to the device under test. Your device should have the ability to descramble, and only then would the recommended image which is transmitted by the AWG would be seen on your sync device. Now let's look at the difference in the test methodology between 1.4b and 2.0 for sync tests. The major difference is in the sync jitter tolerance test and the intra-pair skew test, which now needs a 112 picosecond delay line to be first applied on the positive leg of the differential pair. The tests are performed, then these 112 picosecond delay lines are then manually moved to the negative lane, and the test is performed to its completion. The remaining tests, whether it is the differential impedance test or the min-max test, remains very similar to what we did in 1.4b. One thing to note, as stated in the source test discussion, 1.4b CTS tests have to be applied for your HDMI2 sync device because they have to work with devices which are 1.4b. That means backward compatibility is addressed by ensuring that your HDMI 2.0 sync device is tested not only for 2.0 but also for 1.4b. From the test equipment point of view, the customers who have been using our AWG7122C can continue to use it for HDMI 2.0, while they have an option to migrate to the new generation AWG7002A, which will give a much better flexibility in terms of future proof and also can be used for margin test. The oscilloscope bandwidth needs to be 16 GHz, or we also support a 12.5 GHz scope for HDMI 2.0. The new fixtures for 2.0 and at least 2 probes for signal verification are needed, and option HDM and HDM-DS, which are the new nomenclature for compliance test software for HDMI 2.0, is required. And since 1.4b backward compatibility is must, you will also need to have the 1.4b compliance solution of Tektronix, the software option HD3 and HD3DS. This completes the requirements and differences which are between 1.4b and 2.0, and a complete solution for HDMI 2.0 sync electrical testing. Here is a quick insight to the Tektronix HDMI 2.0 compliance software. The same user interface what you saw for the source testing. You've got tests to be selected and resolutions to be selected, and you can perform one test at a time, or you can perform all tests one after the other in a sequential fashion. The software guides you through the CTS procedures automatically and gives a pass-fail kind of verdict at the end, which can be captured in a report which can be shared across customers. Here is a quick insight on the complete solution for HDMI 2.0 receiver. We are planning to align the announcement as soon as the MOIs are approved by the HDMI forum. The software is available for evaluation. Please contact your local sales team for further details. We have got the full solution for source testing, including probes and fixtures. As we saw, the receiver solution is leveraged using the industry leading arbitrary waveform generator AWG7002A or the legacy AWG7122C. We also learned in this webinar that HDMI 2.0 products should also be tested for HDMI 1.4b to ensure backward compatibility. And for further details on demo and evaluation, please do contact your local Tektronix sales representative, and we can work towards showing you the capabilities of our solution. We have learned in this webinar about Tektronix HDMI 2.0 compliance solution capabilities, a quick snapshot on what other high-speed serial standards Tektronix supports. We have solutions for MHL, DisplayPort, Gigabit Ethernet, DDRA, SATA, PCI Express, the new generation PCI Express, SAS, and not to forget RF capabilities in terms of using the signal view software. We have got solutions for your transmitter testing. We leverage the real-time oscilloscope. We have the ability to generate these signals using our arbitrary waveform generator or bird scope. We also perform the TDR measurement using our industry-leading sampling scope, and a whole portfolio of compliance test software to meet each of the specific high-speed serial standard needs. Not to forget the logic analysis capability which have been industry leading all these years. We have discussed in this webinar the solution from HDMI for HDMI 2.0 for design, compliance, verification, and debug. Look out for a webinar on how Tektronix enables deployment of HDMI products, how Tektronix enables quality of service of your networks which are transporting HDMI, and a quick insight on what we are performing or providing customers in terms of waveform monitors or picture quality analyzers. So the next series of HDMI seminar will be focusing on this deployment network needs from Tektronix solution portfolio. Thank you very much. We now open the session for questions. Please do send in your questions using